For almost 100 years, we've told ourselves a story about the universe. A story that begins with an explosion. A story where space itself stretches, where galaxies drift apart like dots on an inflating balloon. It's elegant, it's powerful, it explains so much. But what if the story is incomplete? What if the universe isn't expanding the way we think it is? And what if that changes everything? In 1929, Edwin Hubble made an observation that reshaped modern cosmology. He noticed that distant galaxies appeared redshifted. Their light was shifted toward longer wavelengths. The farther away the galaxy, the greater the shift. The interpretation was revolutionary. Those galaxies weren't just moving through space. Space itself was expanding between them. This idea became the foundation of modern cosmology. The expanding universe, the Big Bang, cosmic evolution, and eventually dark energy. It all rests on one central assumption. Redshift equals expansion. But what does redshift actually tell us? It tells us that light has been stretched. It does not directly tell us why. We interpret redshift as the stretching of spacetime itself, as galaxies carried apart by expanding space. And the model works remarkably well, but it is still an interpretation. We observe light, we measure wavelengths, we build equations, and from those equations we construct a picture of reality on the largest possible scale. Now something strange is happening. When scientists measure the expansion rate of the early universe using the cosmic microwave background, they get one number. When they measure it using nearby supernovae and galaxies, they get another. Not slightly different, significantly different. This discrepancy is known as the Hubble tension. Two methods, two answers, one universe, and the numbers refuse to agree. This may seem like a technical detail, but it isn't, because the expansion rate determines everything. The age of the universe, the size, its future, the behavior of dark energy. If the rate is wrong, then something in our model is incomplete. In 1998, astronomers discovered something even more surprising. The universe isn't just expanding, it's accelerating. Galaxies are moving apart faster and faster over time. Something appears to be pushing space outward. We call it dark energy, but we don't know what it is. We have never detected it directly. It makes up nearly 70% of the cosmos. Yet we only infer its existence from its effects. Dark energy is a name for something unknown, a placeholder in our equations. And here is the unsettling possibility. What if the acceleration isn't caused by a mysterious energy? What if our understanding of expansion itself needs refinement? If that were true, dark energy might not be a force. It might be a misunderstanding. There are alternative ideas. Perhaps gravity behaves differently across billions of light years. Perhaps spacetime has properties we haven't fully mapped. Perhaps the large-scale structure of the universe is more complex than our simplified models assume. None of these ideas have replaced the standard cosmological model, but they exist because the data leaves room for questions. And in science, unanswered questions are not weaknesses. They are openings. If the universe is not expanding exactly the way we think, then our cosmic narrative changes. The Big Bang might require reinterpretation. The ultimate fate of the cosmos might not be endless cold expansion. The role of dark energy might shift. Even the geometry of spacetime could appear in a new light. But here is the deeper truth. Even if the current model survives every test, the fact that we are still questioning it matters. We are not observing expansion directly. We are interpreting ancient light, photons that traveled billions of years, subtle fluctuations in background radiation, tiny variations in brightness from distant supernovae. From fragments of information, we build a story about everything. And that story is still being refined. The universe is probably expanding. The evidence is strong. But the details, the exact rate, the mechanism, the ultimate cause, are still under investigation. At the largest scale imaginable, certainty becomes fragile. Cosmology may feel complete, but it is one of the most active frontiers of human knowledge. The more precisely we measure the universe, the more the tension grows. Not tension in space, tension in understanding. We thought the greatest revelation of the last century was that the universe expands. But the greater revelation may be this: we do not fully understand how. And that means the cosmos is still teaching us, still challenging our assumptions, still forcing us to rethink space, time, energy, and reality itself. The universe may be expanding, but our understanding of it is evolving even faster, and that changes everything.